school, and I am so impressed and a slightly bit overwhelmed by the turnout today. Thank you so much for coming. It says so much about your devotion to your kids and possibly your math knowledge, but we're going to get you there. I want you to think about getting to Hamad Airport. It's Friday morning and you need to get to Hamad Airport. Think of the route that you would take. Personally, from my place, I could go many ways. However, on Thursday afternoon at about 5, my route to Hamad Airport could be very different because I know of the traffic. I would avoid the roundabout down here for any reason at all. Midday on another day, I might already be at Bellagio, so I would take a different route. That's the attitude we have about math now. We should have strategies that fit our needs for the particular situation. It's not that we have one way to add, one way to subtract. We may be in a situation where that doesn't make sense. We know we have calculators at sometimes. I know driving through McDonald's with 3 kids in the back seat of my car, I am not going to pull out a calculator. I'm going to use a different strategy. So I'd like you to keep that thought in mind. The strategies that we're learning today are just that. They're routes to get to your answers. We need to be fluid and flexible with them. Yes, you are going to like some better than others. Some are going to be more efficient, but there's always times when we may revert back to one of the other ones. It might be simpler, it might be more complex. So, the first thing I would like you to do, I think people will look like they've noticed, or they've discovered, there is a packet in here. We're going to work on it so that when you go home, you have something to refer back to if it's a little fuzzy. We don't learn things well the first go round. So this is kind of your note-taking piece. We are filming it. We're going to see how well this works. If the film turns out well, we'll also make that available to you so that you can refer back to it. Okay, the first thing I'd like to talk to you about is number bonds. Number bonds is simply a way of representing a number and breaking it into parts. There are no strict rules about it. I could have the number 27. I can break this apart in many different ways. I could break it apart as 20 and 7. This one is very neat and organized with circles. Have I done it anything different? Of course, I just chose a different number. That's okay. If I broke this into 15 and 5, that is still a number bond. There is no rule that it has to be circled, that it has to go down. It's about breaking apart numbers. And I'm going to throw in some math vocabulary that your kids are used to. This is called decomposing. Decomposing is when things break down, be it food, be it leaves, be it numbers. So we call this decomposing or decomposition. It can look many ways. Not sure why you would ever do it this way. That's 14 and 4, but the situation might arise. It does not have to be just 2 little bonds. It depends on the need of the problem. However, there are some ways that we tend to use number bonds. The first way, we're talking about making a landmark or friendly number. Landmark and friendly numbers are usually in that powers of 10. I can add things to 10 and beyond very easily. So, in first grade, we are showing kids how to decompose the number 8 so that I can add it to 7 easier. I'm fine with the number 7. I'm not going to decompose it. I would like to break apart my 8 so I can add this up mentally in my head. To go to a friendly number, I know my tens facts. 7 plus 3 is 10. So I'm going to use 3 from my 8, and that leaves 5 more. As kids and adults and all mathematicians get used to this flexibility, this actually becomes a very mental math strategy. So I can go 7 to 3 is 10, now plus 5 is 15. I'm making it easier for myself. These are called The number 10 is a benchmark or a landmark number. We call them friendly numbers. 100 is easier for us. If you're American and you use quarters, 25 is an easy number for you. If you're not, 25 is not an easy number. So there's no rule about what a benchmark number is. It's something that makes it easier for you. When your numbers end in zeros, they tend to be easier numbers to keep adding on to. So, if we have 57, how might I break apart 15 to make this so I can add it up quickly? Yeah. So now I can go 57 plus 3 is 60, plus 12 is 72. Now, second grade, your kids are at different places here. They might even break this up into 10 and 2. Whatever we need to do to keep making it easier for them. This is sophisticated at second grade, but you're going to have some kids that latch onto it and fly with it. Others are going to write it, they're going to fly with it mentally, and others we're going to keep writing it down. This is a number bond system. Would you go ahead and do 190 plus 130, whatever way you would like to? I've kind of set it up. Most of us probably did it the same way. Turn and look at people, the other papers at your table. Did they do it the same way? Did they think about it differently?
Yes.
Okay, so this is number bonds reaching towards friendly numbers. It's a good system. We can also do number bonds where we're really decomposing to place value. We're getting into bigger numbers. We're trying to find a system where we can add them up accurately. I very easily could want to break this into my 3 place values. To begin with, I'm probably going to do both numbers. To begin with, I'm going to keep adding. I'm going to write down 200 plus 400. Now, in the classroom, your kids have been doing this manipulatives. They know, or should know, that they're putting like place values together. So 200 plus 400 equals 600. I have 30 plus 20 equals 50. And I have 6 plus 1 equals 7. Some kids will immediately go, oh, that's 657. Kudos to them. Others are going to write it out. Kudos for them for knowing what they need to do. The more they practice it, the more they're going to be comfortable with it. But they're seeing this broken apart into the place values, so they're understanding what it does. Now, what if your child, being the delightful creative one, decides to do 1 plus 6? They're right. It's there. We do have a 1 and a 6. The order doesn't matter. They are going to come up with the same number. In addition, we can add them up in any order. It's all fine. The only thing that I would do is that if your child does that, watch to see if they're doing a pattern or a routine. You would want to see them kind of approaching the problem the same way so that they're used to checking themselves. If they're random, that's when you can start losing pieces. They're probably going to move on and not need to decompose both numbers. So at 582, I could take apart my 117 and write out my same problem. 582 plus 100, and I'm going to let you guys do the rest of it. obviously didn't solve it, so you can check with each other to see if you got the right answer. I do want to let you know, first grade is using this. Kindergarten, probably not much because they're not writing as much. I walked into a 5th grade classroom today where they are starting to multiply fractions. They are using number bonds. This is a strategy that works through many types of numbers. So you've just passed the first strategy. Can you go ahead and move on to the next page? This is taking the same mental strategies that you were working with number bonds and putting it into a different way of writing it down. This is more sophisticated than the number bonds. It builds upon that knowledge and that understanding. Arrowway is rather a new way for me to look at writing math, and it solved a huge problem. So what we're going to do is we're going to take 42, and I'm going to think a bit like a number line. In my head, I'm breaking apart the number 53. I want to add 50 next. So I'm going to write that down. I'm adding 50. What's my answer? Or my partial answer? I'm at 92. I need to add 3 more. And I get an answer of 95. The reason this is important mathematically is kids tend to put an equals sign here and then add on 3 more and put an equal sign, and that is absolutely false mathematically, because then you have 42 plus 50 equaling 95. I call this the stream of conscious. This is actually what we do when we're doing mental math. We're now giving kids who said, oh, I just did it, we're giving them a way to explain their thinking to us. Okay, let's everybody do the next one together. In general, we're breaking apart the second number. I broke those both apart by place value. We don't always have to. Just like number bonds, there's times when finding friendly numbers or the number seems too big to me that I'm going to break them apart differently. 124 plus 39, excuse me, I'm copying the problem. 124, what am I going to do? I am going to add that first 30. So now I have to add 9. When I have to add 9 plus 4, I'm going over a place value, and that's where kids can get messed up. Well, wait a minute, I don't have to do that in one step. I can add plus 6 and get 160. I've got 36. I need to add 3 more, and I get 163. Now, your kids are being shown this. They're also practicing thinking and asking questions of themselves, of double checking, did I really add the total 39? I'm teaching to you the very shortened version, the quick and dirty version of this. Your kids are learning this a lot slower and with a lot more practice at each of the type steps. So it works for addition. Does it work for subtraction? Yes, sir?
So by second grade, do they know, well, I guess from 154 to 160,
They
they would have to, whatever.
And if they don't, what can they do?
Yeah.
I mean, you're taking it down to these steps that they can go back to whatever strategy they need. Second grade, I'll give you the end of second grade, they should know all of their math facts up to 20. And really knowing them up to 10 is what gives them this flexibility. So they really need to understand and know those math facts up to 10. Once they're expected to know up to 20, but you've got strategies of how to use that. Okay, for subtraction, first thing I'm going to do is subtract 400. Oh, let's do it differently. I'm not comfortable with 400. I'm going to subtract 100. I can get to 736. I can subtract another 100. Okay, I can see I've subtracted 300. I'm supposed to subtract 400. I need to subtract another one. So now I'm at 436. I need to subtract 5 more, and I get 431. Those are choices your kids can make. Most of them would probably be comfortable subtracting 400, but if not, you can do it in the smaller steps. Would you go ahead and do the last one? For most kids, if we really practice this understanding of our number bonds and breaking apart numbers, this is going to be the easiest way to deal with that 90. Get them down to a number they're comfortable with, a nice friendly number, and then they can go from there. You will be seeing this come home. I don't think it'll be homework yet, but your kids are starting to do this arrow way right now. Smaller numbers, a little bit, friendlier numbers. The size of the number doesn't make as much difference as how, 438 is not a nice number. Any questions about what could happen or what? Mm-hmm.
So, okay, my son had one last night, and he gave me the answer. I'm trying to understand how he did it, but he actually figured it out. He did it instead. And to me, because I don't know his way, so I was trying to show him all this wrong subtraction. I was trying to carry ones and things like that. He's like, no, I didn't. What did you do? And so, yeah, now I feel
Yeah.
like he's doing.
So we should have done this yesterday, but it was sports day. Yeah.
Okay. So then
This
I'm
to
doing-
me is the exact answer to kids who said I did it in my head. I was like, absolutely you did. I just want to know which steps you did first and which you did second.
So they're not doing one subtraction or one addition?
No, not in second grade. And I'm going to talk to you specifically by the end of this because I'm going to show you something that looks like it. Please do not go there. That is a very, very, very abstract column thing. They're just, some kids, well, I'm going to stop there. You'll see what we get to, and you'll see that even on the bottom of my sheet it says, please. This is about reporting their actions, not about using the column way. They'll get there. They'll get there, and they'll be really well prepared for it once they get there. Okay. I want you to pat yourself on your back. The next one is probably the coolest thing I learned as an adult. You're going to need your Unifix cubes. If you could try to grab this many of 2 different colors. I think they're in groups of 10, so you'll need 2 different colors. We're going to start with a nice, easy problem. Let's do 8 of one color. So we're going to do subtraction today. This is called compensation. Subtraction has a couple different ways that you can act things out. And one is straight takeaway. Perfectly fine. talk about the other way today because most people don't think about it. It's called the difference model. In mathematical language, the answer to a subtraction problem is labeled the difference. If you take a look at your 8 and 5, go ahead and put the 8 on the top, line them up with your 5 on the bottom. You can see the difference of 8 and 5. How many is it? 3. Okay. I feel like I'm now doing magic. 8 and 3, perfectly, or 8 and 5, perfectly easy to do. What happens, and some of you, I'm sorry, due to the numbers, you might have black. What happens if I add one more to each of these numbers? What happens to our difference? Stayed the same. What happens if I add another one to it? The difference stayed the same. Okay, let's say I didn't. What if I took one away from each? What happened to the difference? That means we can play with our numbers and get them to friendlier numbers so we can do the subtraction. Now, we don't have enough cubes. We can also draw this. So if I had 8 and I had 5, I'm not sure on this problem why I would do it, but I could add 2 and I would get the problem 10 minus 5, and I'm so good with my 10 facts that that made it easier for me. So that's as much as you get to use the cubes, because we're going to go to drawing. Thank you. That was bound to happen. 10 minus 7, and it remained the same. And please do correct me, because that would be very confusing to other people saying, no, it should do that. It was 10 minus 7, because it's 8 plus 2 and 5 plus 2. Okay, so let's look at the first one in the page. We have 25, and I'm going to compare it to my 8. (25) minus 8 isn't that easy of a problem. I mean, it's 8s and 7s and crossing over a 10. I personally would add 2 to this, and then I would then get 27, that's a minus sign, minus 10. 27 minus 10 I can now do easily. It equals 17. You know what? Not every one of these is going to work for every single person, but if you keep trying it, they start to make sense. They will be using this in this unit. So what we're trying to do is to get to friendly numbers. I may not have made that clear enough to you. So the 8 became 8, yeah. Poor 8 was never a very friendly person. No. So we're trying to get to a number that we can subtract easily. Okay? 34 minus 19. Draw 34. I'm going to compare it to my 19. Is that particularly easy? Not for a second grader. If we add one more, I now have 35 minus 20. Yeah, I would much rather do that.
So is there a rule when you make the second number friendly?
You just read my mind. What I was going to show you after doing 3 is take a look at which number we kept making friendlier. In general, you want to make the second number the friendlier number, because that's the one you're subtracting from, or taking away. It's not a rule, but in general, that's what's going to happen. So go ahead and try 73. Talk to your partners. What would they do? 73 and 16. Can I repeat a question? We got to 100 or 250 minus 130. They're both zeros. We look at the tens. They seem easy enough to do because there is none of that regrouping. This is why this problem was put in here. Would you use this strategy? Probably not. You could use the arrow way, you could use number bonds, you can use other strategies. We want you being critical thinkers. And the business world and the universities are telling us what we need in people, and the next generation that's going to take care of us is critical thinkers. To be honest, we have calculators, but we need people making decisions on what's the best way to do this, and is that answer on the calculator reasonable? So go down. What are you going to do to 700 minus 152? I'm going to give you a thought. What if I take away 1 from both? So now I have 699 minus 151. And I don't have to do any of that breaking apart at 10, borrowing from next door, giving it over here, the whole standard algorithm. This one is actually, although large numbers, there's no regrouping, and a lot of kids could do this without much more thought. This is high level at 2nd grade. This would be to challenge the highest kids of why would we do this, and can you recognize this? So I am showing you from the very beginning stages to how we are challenging high kids. But at this point, many of the kids could do 600 minus 100 is 590 minus 50 is 40, and 9 minus 1 is 8. Or they can take their 699 This is wrong. Yeah. Where am I making my mistakes? 549, I wrote it down wrong. There we go.
549.
Yeah. But this difference model isn't something that I was taught. Granted, I'm older than everybody else in this room, and it really hasn't been taught a lot to kids, and it really is a rather elegant solution.
Why would you put this option? If you wanted to see, whenever I have
I think it's when you start recognizing that you can get these to friendly numbers pretty easily.
The last one.
Yeah, the last one, I almost took it, I did it the other one. I think it's kids start recognizing when they have to regroup across zeros. That's what made that difficult.
Why would we not take like hundreds, like just take something and add this and then, you know, like arrow way, you just subtract 100 and then 50 and then.
And you could.
Yeah.
And this is where it becomes very, very personal and what you're used to in your subtracting. You could do 700,
Minus 100 and then minus 50 and then minus 3.
It's this step right there, the minus 50, that could trip up some kids because you're having to regroup 100 into 2 to 10 tens so that you've got the 50. That would be a lot. But
Why
there,
would we do something like 699 and then, I'm sorry, I just kind of missed the method that you were doing.
well, I just switched it over to the arrow method but with the new numbers.
Okay.
So I got here, I still needed to find this still isn't a solution. So now I needed to do the next step, and I chose to do it the arrow way. We now are teaching kids to look at numbers by place value. Will you have to regroup? And then they make decisions on how to solve the problems by whether they have to regroup. We're going to get the answer. We're going to get the same answer no matter what. So what I did was I got it down to a problem that the arrow way was going to be pretty simple. As I said, this was a very sophisticated problem. Now, your kids are going to be taught number bonds and the arrow way and this next way of using manipulatives. Then they're going to circle back and they're going to do number bonds at more difficult problems, arrow way at more difficult problems. So we're going to move on. You would turn. Now you get to play with your baggie. We are calling these number tiles. I'm going to be honest with you. You may get worksheets home that call them number discs. I hope that you can appreciate that a disc is round and a tile is square, and that is the only difference between them. We owned tiles. We saw no reason for going out and buying another plastic set of things just to make it round or square. Your kids in class have these on plastic. You're getting them on paper, but we did even match the color that your kids would have. So we're going to get into building problems. We are asking the kids to write them out in certain ways just to help them visually see what's going on. And this is where you're going to, first time you're going to see what looks like column addition and subtraction. I would argue it's not, because really what we're doing is just writing down what we're doing. It looks the same. Does it lead to that next step? Sure, but it is not what we're expecting from second graders. We're expecting them to build it and or draw it and then keep track of what they're doing. In their keeping track, that's what ends up looking like the traditional column addition and subtraction. Okay, you're probably going to want to get your tens together and your ones together and your hundreds together. I think most of you got 1,000, but that was just because we're not. Second grade goes up to 1,000. We don't work in the thousands. And in your basket, you also have a place value chart. Could you go ahead and build 214? We do build it by place value as efficiently as possible. And I would like you to add to it, let's add 360, being careful here, 365. At this point, your kids are being asked to keep them separate so that you can still see the two numbers. So you do it in a second row. We are linking the building it to the abstract writing as we do it. I will confess that several years ago, I would have done all the manipulatives one day, good, you got it. Then I would have done all the drawings a few days, good, you got it, and then go to the abstract. We should be linking them as they go. So we have 214 built, I can see it. I have 365 built, I can see it. How many ones do I have? I have 9. I've counted them here. I'm making my notes over here in my column. I counted them. I didn't say 4 plus 5. Looking over here, I am looking at what I built. I do know that 4